So it's always a pleasure to be here, especially among dear friends as Marconi, George. And we'll be talking about the influence of the posterior interface of the cornea on the total power of the cornea, and especially astigmatism and the spherical power. I do have some conflict of interests, and they are due to applied patents, but nevertheless, none of them is related to the topic of this presentation. So, since Helmholtz, listing, and Gauss-Strand, we do know that there is a relation between the anterior surface of the cornea and the posterior surface of the cornea, in such a way that the posterior surface of the cornea diminishes the power of the total cornea, and it's believed that there's a ratio between the anterior and posterior power of the cornea, and this ratio varies from 0.8 to 0.9. But every single data so far was based on normal eyes. This ratio is used to create or to estimate an artificial refractive index for the cornea that compensates for the posterior surface of the cornea. Again, since the first keratometer has been created, we use it. Although the cornea has approximately 1.376 refractive index, we do use smaller ratios or smaller refractive indexes to compensate for the negative power from 5 to 7 diopters that the posterior cornea has. Although, to calculate this ratio and this influence in refractive indexes, we did have to make some assumptions. The first is, it is a constant factor between the anterior surface and the posterior surface of the cornea in every patient, in every kind of eye. And the second one is that this relation is constant, and the cornea has a constant thickness. So with these challenges, with these assumptions, we do have a very good accuracy in determining the total cornea of the power, measuring only the front surface of the cornea. Although, in this work, we challenge both of those assumptions. We know, since we began analyzing the posterior cornea, the posterior surface of the cornea, with the seminal papers from Carlos Arce and Renato Ambrosio and Michael Bellin, we know that the keratoconus eye has a different progression of thinning, and they would progress more aggressively towards the apex or the thinnest part of the cone. And the very good tool for that is to use the map of thinning progression, and we can see clearly that a keratoconus eye does not follow what has been determined as a progression of thinning in normal eyes. So, in a normal cornea, the ratio between anterior and posterior surface can be very, very predictable. In normal corneas, being it a stip or flap, this ratio will maintain constant. But if we assume that the keratoconus begins with the thinning of the cornea and then that will lead to a progression of the steeper cornea, we have to assume that this ratio has been changed. Because if we have the thinning of the cornea, we will have a more curved posterior cornea. So in this example, in details, we use a Gauss-Strand model and a theoretical keratoconus eye. So the normal Gauss-Strand eye says that the anterior surface has 7.7 millimeters of anterior curvature. That would lead to a 43.05 diopters using Olsen 1.3315 refractive index. Gauss-Strand says that the posterior cornea has 6.8 millimeters of curvature. If you go to the keratoconus, we have a steeper anterior surface of the cornea and an even steeper posterior one. So in this example, that was a theoretical example, it goes from 7 to 6. So in a normal eye, I would have a ratio of 0.883 And in a keratoconus eye, I would have an ratio of 0.857. That means that in the keratoconus, the posterior surface of the cornea has a much higher influence than the anterior, but this is theoretical. So the method for this work, we analyzed every single exam that was performed in 7 years in 3 different institutions in Brazil. We began with almost 72,000 exams, but there were more than one exam for the same eye. After we excluded it, we had 33,000 exams of single eye exams. We did remove every single exam that was considered by the instrument itself as unreliable or abnormal or post-corneal surgery, as well as the corneas that have a flattest K of less than 37 diopters, because we could have post-operative patients among them. It led us to 24,000 eyes. So those are unique exams of one eye from almost 26,000 patients. From those, 16,000 were normal and 7,000 abnormal or had keratoconus. We did use one of the tools to classify the keratoconus, and the TKC comes on the pentacam and gives me 9 different classifications for keratoconus, from normal to grade 4. Now, if we look here, we can see that normal eyes, this ratio was 0.82 as previous works have showed. Possible keratoconus, we could not detect any difference. As we go for more advanced keratoconus, this ratio goes down as expected, exactly as expected. Notice that the TKC grade 4, we had only 10 patients, even though this is smaller than this, statistically significant. So just to look at it graphically, just to make it easier to understand, we separated between the normal eyes and the keratoconus graded 2 to 4. So if you look here, and I'm plotting it against another index just to see the plot. So we have the back-front ratio varying here from 0.75 to 0.85 on normal eyes. And if I go forward, I can see the same thing on the keratoconus eyes. They spread much more, and they have They spread much more, and they also have a more influence. It's shifted to the left. So in conclusion, the back-front ratio has been very well determined, but only for normal corneas. Keratoconus corneas present a different back-front ratio with a greater influence of the posterior surface. The more advanced is the keratoconus, the greater is this influence. And formulas that estimate total corneal power and therefore the astigmatism should not be used in eyes with keratoconus. So if we're not sure if we have to map the posterior surface of the cornea, we should be more aware of this influence in keratoconus eyes. Thank you very much.